and were like waiting to get in that environmental science class, and they couldn't get in. Waiting room cutoff. Yeah, start that video. All right, get us a smart notebook screen. Where's that at? I'm losing my buttons. Hmm. Yeah, that'll work. Right. Myself a thumbs up so I know I'm editing to this point. There we go. All right, so yesterday we did ionic bonds. There's two more types of bonds we're going to talk about today. One we're going to talk about really, really fast and not say anything else about because it's easy. And the other one we're going to spend the rest of the day on. But before we leave ionic bonds, we got to deal with a special type of molecule that can undergo an ionic bond, and that's called a polyatomic ion. Now, that seems like a big crazy word, and it seems complicated when you hear it, but if you break it down, it's really, really simple. You already know what an ion is. Anything with a, talked about it yesterday, anything with a what? Yeah, anything with a charge, anything that's positive or negative. So these guys have a charge. We know what an atom is. Poly. Poly means more than one. Many, more than one. So this is just an ion that's made of more than one atom. And the cool thing about polyatomic ions is that all of their names and all of their charges and all of what they are is always given to you for free. If you got one of your yellow sheets from me, if you're one of the folks at home and you got one of your yellow sheets from me, you just turn to page 7 on that yellow sheet, and there's the polyatomic ion chart right there. Okay, polyatomic ion chart. If you don't have a yellow sheet, all you have to do is Google polyatomic ion chart, and it'll give you all of the polyatomic ions that exist. You never have to remember them. All you have to do is look at that paper and see what it is. Now, the thing about polyatomic ions, whatever they are, they have to stay that. So if you see something off the polyatomic ion chart, you can't change any of the amount numbers. Okay, so let's give you an example of that. Let's do aluminum sulfate. Okay, first part of that is easy. Aluminum is what? Al. Al, we did that a bunch yesterday. Now, we'll talk about this more in just a second. But the next thing you need to do is figure out what type of bond it is. Aluminum is a metal. Anytime you start with a metal, you're going to be dealing with an ionic bond. How do I know aluminum is a metal? Because of common sense, right? Aluminum is a metal. But also, you look at a periodic table, anything to the left of the stair step is a metal. Now, you can't really, you can sort of make out the stair step up there, but on your yellow sheet, if you turn to the middle, you can really see the stair step right there. Anything to the left of the stair step is a metal. Anything to the right of the stair step is a non-metal. If your first element is on the left of the stair step, you have a metal, which means that you're going to have an ionic bond, which means both things are going to have, if it's ionic, what's my magic word with ionic? You already told me? Charges. What's the charge on aluminum?
13.
13 is the group.
No, it's also
positive 3.
Okay.
Plus 1 is group 1, plus 2 is group 2. You skip 3 through 12. Group 13 is positive 3. Everybody with me? Now, sulfate. This is what's new and different about today. Now, yesterday, when you would have done it, you would have always ended in what three letters? Ide. Sulfide means you go get sulfur. There it is. But this is sulfate. Anytime you end with something that is not IDE, that means you got to go look at the chart. So look at the chart, and I want you to tell me exactly what it says for sulfate. SO3. Look again. SO4. SO3 would be sulfite. Okay, this is why it's important. Those letters are very important. What was the charge? -2. Now, I don't love the font on these papers because it kind of looks like this number is behind that number. I don't like that because these numbers will always be together. You can get rid of your charge. You can move your charge around. You can crisscross your charge, but those numbers you can never, ever, ever change. Get that out of the way. Oh man. Let's just rewrite it. As a, so we read sulfate. Sulfate is an SO4 with a -2 charge. Sorry about that. With a -2 charge. Now, what do we do with our charges? Crisscross. So this -2 charge tells me I'm going to have 2 aluminums. Now, here's where it gets a little sketchy, but way easier than it looks. That +3 means we're going to have 3 whats? Don't worry about protons. That's true, but that's not what I'm asking. The -2 means you have 2 aluminums.
But
The +3 means we have 3 whats?
there's a 4 there.
True. What'd you say? Don't worry. You're thinking too hard. Sulfates. What is sulfate?
Isn't it sulfur?
It's on the board. Sulfide is sulfur. What is sulfate?
That's up.
Keep talking.
That's up 4.
Correct. How am I going to show that I have 3 SO4s?
Put the 3 in parentheses.
Excellent. We're going to add some parentheses.
Okay.
Aluminum sulfate.
Well, why is that 4 there then?
That 4 is there because that 4 is a part of sulfate. Sulfate is not SO. Why are you looking up there? Sulfate's not up there. Sulfate's on a yellow sheet right there in front of you. Sulfate is SO4. Sulfite is SO3. You cannot get rid of this 4. You cannot reduce this 4. You cannot change this 4 in any way because sulfate is SO4.
Okay. Now I get it.
Everybody with me? Let's do another example. Let's go the other direction. Let's go the other direction, and let's say that we have
Bromate.
I need my yellow sheet so I can make some up. I got it. I need my yellow sheet so I can make them up off the top of my head. Sorry about that, guys. It's been a while. Let's say we have TiClO3 2. TiClO3 2. All right. Start off easy. What is Ti? Titanium. Now, where is titanium on the periodic table?
On the left.
On the left, which means it's a metal, which means that my charges matter, which means it's ionic. Excellent. But where specifically is it?
Group 4.
In the middle. What do we not know about the middle?
They're weird.
They're weird because we don't know their whats.
They're charges.
Very good. Since I don't know their charges, what am I going to have to write with titanium? A parentheses for a Roman numeral. Excellent. So let's put that parentheses up there, and let's come back and get that Roman numeral. Now, this is a whole bunch of different atoms. What word, I'll get you, what word did we use today that means a whole bunch of different atoms? Polyatomic. So we go to the chart and we look up what is ClO3.
Chlorine.
And you write it exactly like it says. Chlorate. This is where you have to be very careful about your letters, because chlorate is different than chlorite is different than chloride. So that's changing one letter each time and getting a completely different chemical. You have to be very careful. Okay? So we have titanium something chlorate. What's the charge on chlorate?
Negative.
It just says negative. What number do we leave off in chemistry?
1.
-1. Did that -1 crisscross down and give me 1 titanium?
There's iron. Titanium iron.
Did it give me 1 titanium?
Yes.
It sure did.
That means 2.
What's the charge on titanium?
2. Okay.
Kicking times line 5. All right. Let's try, well, we got lots of practice on those, so I'm going to save the practice. I'm going to make sure that this is as short as possible. So practice on those. Let's add our one more thing so we can cut the Zoom, okay? All right. So that's polyatomic ions. Real quick, I'm going to mention metallic bonds. We don't really have much to say about metallic bonds because we don't really name them. Ionic bonds are metals and nonmetals. The metal gives away its electron, the nonmetal takes its electron. Metallic bonds are where you have a metal bound to a metal. They both want to give up their electrons.
So we have to add a proton?
We had a problem.
So like not a proton,
And so
non-metal?
what metal? No, because there is no non. It's like in a solid piece of gold, there's no nonmetal there. It's held together by metallic bonds. This right here is held together by metallic bonds. And how it works is all of the atoms give up their electrons, and the positive atoms are held together by the negative ocean of electrons. And I'll explain what I mean by that, okay? So all the atoms give up their electrons, their valence electrons. Which means that all of the atoms are, if they all get up their electrons, they're all what? Other way, they're all positive. So the positive atoms are attracted to the negative C of electrons.
So is it kind of like a half and half split of all the atoms on one side, like C of
Nope.
negative on the other side?
Nope. It's all of the atoms. So think about this right here. This piece of metal is an alloy. It's got more than one element in it. But all of these metals are being held together. Every single atom in this podium is a positive atom. But it's held together because those positive atoms are surrounded by shared electrons that go everywhere. This is why if I hook up a battery, car battery, to this side of the thing, and then I grab the bottom, what's going to happen? It's going to electrocute me because the electrons have no problem going all the way through this. It's also why if I take the hammer and hit it, what's it going to do? Bend it, because the atoms just slide by each other. Whereas if I hit this,
It's gonna possibly crack it.
it's going to crack or break because the atoms can't slide, because instead of metallic bonds, it's held together by something we're going to talk about next. Nope, covalent bonds. This is held together. If you have a salt block cracks apart because it's held together by ionic bonds. This is held together by covalent bonds, which is next. Okay, so ionic bonds, metal versus and non-metal. Metallic bond, metal and metal. We're not going to say anything else about it because you don't name them. You just name them whatever the metal is. If you have a metallic bond full of gold, you call it gold. Rock and roll? All right.
So what if it's like gold and silver?
It'd be hard to mix together gold and silver, but you just say that you have a metal gold and silver alloy.
Okay.
Yep. All right, let's roll on. So the last one is a covalent bond. And this is going to be when you have a non-metal bonded to a non-metal. Both of them are looking to gain or lose electrons.
Gain.
Very good, because they have 5, 6, or 7 electrons, and everybody wants what number?
8.
Everybody wants 8. So let's check out an example of that. Carbon has how many valence electrons?
4.
Very good. 1, 2, 3, 4. Okay. Hydrogen has how many valence electrons?
1.
1. Now, hydrogen is weird because it's actually not trying to get 8. Which of your noble gases is hydrogen trying to be like?
Helium.
And how many does helium have?
80.
Try again. How can helium have 8? It's only got a total of 2. So helium and hydrogen are the only guys on the whole periodic table, lithium and beryllium a little bit, that are happy with just 2 valence electrons. Most of them are happy with 8, but those guys at the top are happy with just 2 because they don't even have close to 8. Okay, so hydrogen would be happy with only 2 valence electrons. And so what hydrogen does to get happy is it just wiggles over here close to carbon and shares its 1 electron with carbon, and carbon shares an electron with hydrogen.
Like 5, now it's 5 too.
Hydrogen's happy, carbon is on the way to being happy because carbon now has
5.
So what can carbon do?
Get
5, 3 more hydrogen.
What is this thing? Is that carbon dioxide?
CH4. Anybody know what that is?
No. I have no clue.
We're going to give it a name that's not the name I'm about to get it, but it's actually methane. Y'all just ate.
This. Like, is that methane?
That's actually butane, or propane is coming out of there, but it's close. That would be propane. That would be like C5H7, I think.
That's what you're talking about. That's in the CHEMPolyCov common methane. I did that around
There you go. Okay. CH4, methane, this is what you poot out. This is the major gas in your poop. This is why you can light your poop on fire. Okay? This is probably not a very smart idea because you probably light your butt hair on fire too. And that wouldn't be a very smart idea.
I honestly swear to God, I want to do that.
Please be careful. Okay? But CH4 is flammable because of a combustion reaction. We'll talk about that in the next chapter. We'll talk about a combustion reaction in the next chapter of why this thing is flammable. Okay? But let's name it. Now here's the problem. In the last, for ionic bonds, you just were able to name what you had because your charges told you your crisscross numbers. Well, I didn't do any crisscrossing here. And so I have to be able to tell how many of each thing there is. So if I only have 1 and this is the first thing, I just write the name. What is C? Carbon. But if I have more than 1, or it's the second thing, I have to write a Greek prefix. Okay, now that sounds complicated, but I guarantee you probably know most of them. Okay, 4 is a weird one though. So let's learn our Greek prefixes real quick, and then we'll scroll the screen back up and get those. Okay, I only need you to know your first 10 Greek prefixes. And this is just something you got to know. Most of them are pretty easy, but some of them you might have to think about a little bit. 1 is easy because you know what NO is. Nitrogen what? Try again. What word means only one thing? Mono. Carbon monoxide. CO. Okay. 1 is mono.
Oh, that's
2, you know, because you know what CO2 is. Di.
That's carbon monoxide. Is like that's the one like they show where people that close their garage doors.
There you go. Absolutely. We'll talk about that in a bit too.
Okay.
3, you know, because you know dinosaurs. Try. Very good. 4 is tough because you expect it to be quad. That's not. Okay. The easy way to remember 4 for me is video games. We'll give you a little video game history real quick. Okay. When I was little, my cousin had an Atari, but most people I know didn't really have an Atari. Most people really got their first video game with Nintendo. Cool as crap. Okay, had the NES, regular Nintendo, Super Mario Brothers and Duck Hunt. Okay, then the next big thing that all my friends got that I didn't get one because I was too busy working the backfield and doing all kinds of stuff was a Game Boy. Right, and all the Game Boys came with a game. Now the Nintendo came with Super Mario Brothers. The Game Boys came with anybody know?
With the cartridge.
Well, they're all cartridges. Tetris. Okay, and we've all, even if you never played Tetris, you probably have seen Tetris. It's one of the most famous games out there because they lost the copyright to it, and people could just make their own Tetris games and call it other things. So Tetris is one of the most famous games. It's a little puzzle game where you drop the bricks, and the reason it's called Tetris is because every single brick in the game is made of how many smaller bricks?
4.
Tetra is 4.
Have you seen that movie with Adam Sandler? It's like a midget Adam Sandler, and they go back and like.
Let's carry on.
Oh no, Tetris reminded me of it. It was where like all the games, like characters.
Pixels? No, I skipped it. It's supposed to be really bad. I skipped it. All right, we got Tetra. Tetra is 4, and you can remember it because video game Tetris has 4 parts. Whatever. That's one of the toughest ones to remember. It's the one you use the most that you need to remember. Tetra is 4. 5 we know because we know the shape of a 5-sided thing. Penta. 6 is the same thing with shape. Hexa. And 7 is actually with shape too, but it's not a shape you really do very often. I know.
Not poly.
Hepta.
Hecta's 8 though.
No, 8 is. Hecta.
I thought you said hecta.
9 is easy because it sounds like 9. Nano. And 10 is easy because you know what 10 years is. Cento will be 100 years. Decade. All right, so if you need to write that down, if you need to Google it, whatever you need to do, you've got to just straight. There's very few times in this class where I'm going to tell you, you have to know this, but you can't just look it up.
We have to know that.
You got to know this.
You got
Okay? Help yourself. And if that's good, rock and roll. But yeah, you got to know these. And to me, like I said, to me, they're easy, except for you got to remember Tetra, like the video game. And then every once in a while, you'll have Hepta. But the only time you use these, this is huge, because Mr. Salibi actually had some folks in his class that tried to use these yesterday. None of the things we did yesterday were we supposed to use these, because yesterday was all ionic bonds. The only time you use these guys is for covalent bonds, non-metal and non-metal bound together. That's the only time you use these guys. The only time you use these is when you have a non-metal bound to a non-metal. And the non-metal, if you don't have a metal, the non-metal will always come first in that situation. So if you have a non-metal first, then you're talking about these guys right here. And I'll rewrite them over here so I can roll on. So we can refer back if we need it. All right. So let's scroll back up the page and get CH4. C is carbon. What are we going to put for 4?
Tetra.
Tetra.
Is it tetrahydrogen?
Now we got to do the same thing we did yesterday. We always have to end in the same 3 letters.
Tetrahyd.
Say it.
Tetrahyd.
Well, we gotta say what it is though.
Tetrahyd.
What is H? Tetrahydride.
Oh, that's a colossal word. I don't like that. That's a colossal word.
If you put tetrahydride, that's still kind of right. You did the right thing. tetrahydride. Questions on carbon tetrahydride? All right. How about this guy? But I gotta give it a real name. Methane was the real name, was the common name for CH4. H2O. H2O is the water is a common name. But we don't begin with I, we end with I. Dihydrogen. You can't put dioxide. There's only how many O's? Dihydrogen. What word means one?
Mono.
Say it.
Dihydrogen mono.
Monoxide.
Mono. That's like carbon monoxide.
Very good.
How are we doing this stuff?
Dihydrogen. Where you said?
How are we doing this stuff?
Because you gotta have a name. Everything needs a name.
Like the names are so complicated.
No, that's not complicated. No, that's literally telling you what it is. This is the opposite of complicated. Two hydrogen and one oxygen. Okay. Y'all talked about butane in your lighters. C3H8. Tricarbon.
Tricarbon octahydrogen.
Octahydrogen.
What? I'm lost.
Where are you lost? Where are you lost? Tell me where you lost. What part of that lost you?
The whole.
That's not true because you know that 8 is octa and you know that 3 is tri.
Hydride though. Shouldn't you, like we just said something about hydrogen.
Always is that the last one or the first one?
Oh, okay.
You always end
in I.
in I.
Okay.
Okay. It just makes it sound prettier. I don't know. I didn't make that call. All right, let's go the other way. The other way is real easy. And phosphorus pentasulfide and hey, you do it on your own. Do it on your own. Phosphorus pentasulfide and nitrogen triiodide. That's easy as pie. Both of them, I think.
Yeah. Should I do that phosphorus?
What's that phosphorus going to be?
P2S5.
Kicking tires, line 5.
I did it.
Nitrogen?
There's I30.
Triiodide is I3. Now, here's something I saw on practice yesterday. Most of you guys that were in class yesterday did excellent on practice. But and go back if you did your practice. If you weren't here yesterday, or if you do practice later, go back and check your practice because I'm commenting on this practice because I give you 100 for doing your practice, but I'm going to comment so that you don't make the same mistake on the test. Okay? And something I saw people doing yesterday is there was one of them that was, I think it was, what was the titanium one on their practice yesterday?
Titanium 3 phosphate.
Maybe. So it was TIP, right?
Yeah, that's it.
Okay.
Only that.
But I had people write this on their test.
No.
Okay. Here's the problem with that. It might be a capital I, maybe, and it might be right. Always use lowercase for the second letters.
Yeah.
Always use uppercase for the first letters. Always use lowercase for the second letters because this in chemistry class is an L, lowercase L. If you want an I, it needs that.
They basically just that means the thing you just wrote down is
something different. Well, it doesn't exist. There is no TL.
Thallium.
Oh, there is a TL. My bad. You got me straight. All right. Any others? All right, guys, so that's this unit. We got a bunch of practice. The cool thing about covalent bonds is what doesn't matter. What did we talk about yesterday like crazy that we didn't talk about with covalent bonds?
The Roman numerals.
We didn't do any crisscrossing. There's no Roman numerals. And we didn't do any crisscrossing because there's no whats? There's no charges. There's no charges, which is why if I hook a car battery up to this corner of the table and ask you to grab that corner of the table,
I would be fine.
because this is not going to move those electrons. The electrons are staying right where they are. Rock and roll?
Yeah.
All right, guys. I'm cutting off the Zoom. We'll edit this down, and I'll be glad to practice with anybody who needs me.
Yesterday was what, the 7th?
True.